All right, duct fittings and installation. When we are looking at pieces of ductwork on an HVAC system, there's a couple of different pieces that you got to be familiar with. The very first piece that we're going to discuss is what we call the plenum. The plenum is the very first piece of ductwork that is actually attached to the furnace. Okay, in this image here, you can see that the plenum is actually attached to an evaporator coil, as you can see right down in here. So you can have your refrigerant lines right here. This aluminum piece right down in here, this is actually the evaporator coil. The plenum, this piece right here, is that very first piece that gets attached to the ductwork. Okay, the plenum is sometimes called the bonnet. Sometimes you'll hear manufacturers mention that name. Sometimes they'll ask the bonnet temperature or the bonnet piece of the equipment. That portion is what they're talking about, is actually the plenum. Okay, so the plenum is the very first piece. Okay, the sides of the plenum is what we actually cut into so that we can start running in our takeoffs and our branches out to the space. Okay, your takeoffs, these guys are going to usually have a 1/2-inch hem or flange on them. Okay, they may be attached by a clinch type collar. Your sides that attach to the plenum will also have a 1/2-inch hem or flange on them. And this side, the side dimensions should be larger than the duct size to allow air to flow much more smoother. Okay, they should have a 2 to 3 inch rise for that very same reason. So here's an example of a couple of different types of takeoffs that we're talking about. As you can see, they can come in all different shapes and sizes depending on what we're doing. Okay, that very first one, that's just simply a rectangular takeoff that maybe we're just connecting to a first branch of ductwork to feed a certain part of the room or a certain part of a house. You also have your squared around type takeoff where we're connecting this to a piece of square ductwork and then we're going to connect it to a piece of round ductwork, maybe to supply air to a room. The other one on the bottom here, that's the very same type of thing. That's a takeoff where we can actually maybe attach the takeoff to the top portion of a ductwork. Maybe we're going to run the ductwork in between the studs or inside the rafters in a basement or something like that. You also have your 90-degree elbows. Okay, you have your short radius 90-degree elbows, and then you have your long radius 90-degree elbows. This long radius 90-degree elbow right here is actually adjustable. We can actually spin these little sections to adjust for obstacles and other issues. This guy here is a little more set. We can only put it in one place, and it's only going to fit in one place. Okay, as you can see, elbows, we can do a lot with elbows. Okay, we can get around obstacles in homes and in businesses, depending on our application. You also have what we call offsets. Okay, offsets, we basically use these to navigate around obstacles. For example, maybe we have walls that aren't exactly lined up perfectly due to building construction, and we need to get the air from one point to another. We may actually install what is called an offset. So you can kind of see that offset right here in this picture. Here's our return duct. That return duct doesn't necessarily line up perfectly, so in order to make that connection, this person here had to construct an offset. Okay? You also have what are called transitions. Transitions are used if we're taking one piece of ductwork and transitioning it from one size to another. Or, hey, we're even trying to maybe have to change the direction of the ductwork, as you can see in the example of this type of transition. In this piece, the ductwork is actually shorter on this length and longer on this way, but versus it has to change its direction. So you also have stuff like that is out there. Sheet metal is relatively interesting, and it's amazing what you can do and what the fittings you can make when you know how to use it. Yeah, you have your Boston elbow. These are commonly used for a lot of your return drops. This elbow would actually get connected right back on the return side of an air handler, where you would most likely maybe commonly find your filter. Your filter would actually get installed, or your filter rack would kindly get installed right in this vicinity. Okay, and then you would just make your ductwork connections up here. Okay, you also have a different type of transition here, which is commonly called a filter boot. Okay, this is a flange type piece of ductwork that is attached again to the side of the furnace, or maybe a filter housing, depending on what we're dealing with. You may actually run into this if somebody has an electronic air cleaner connected to their furnace. This is a much easier way of making your connections by using something of this nature. You will also run into a radius T. Okay, this type of ductwork may actually get connected to a branch of duct where it's actually going to throw air in two different directions. You may also run this into commonly in commercial, industrial type equipment, where that air is going to have to be thrown in two different directions off of one unit. You also will see what we call a pair of pants. They kind of fits the name. It kind of looks like a pair of pants. Same kind of application, where we're going to be connecting two separate supply ducts, or hey, even maybe two separate return ducts, depending on the construction of the house or place of business. Okay, alternative stuff that you have is obviously you can use what we call duct mate. Basically all that is a slip and drive connection with some gasket to kind of help create a better seal. Then you also have your standard slips and drives. These are very, very common in a lot of sheet metal installations, and this is how we actually connect ductworks together to make our full air distribution system. So you will actually see in this picture here, you have your slips. A slip is what actually makes the connection and holds the pieces of ductwork together. And then you have your drive, which actually creates the actual connection and holds all those pieces together. Okay, your bigger and more industrial type ductwork, you may actually run into your gasketed and bolted ductwork together. This is going to be used for much bigger HVAC equipment that's going to be moving a lot of air and is going to have much higher static pressure than what you would see in a residential setting. So in order for that air ductwork to be held together, instead of using slips and drives, you're actually going to be gaskets and bolts. You will also run into your canvas connectors. Okay, canvas connectors are basically used for vibration isolation. You can use it to kind of help muffle sound of air flowing through ductwork. Sometimes this is what a quick remedy to fix air velocity issues. If people are complaining that they could constantly hear the blower running, or they constantly hear the air blowing through and it's kind of annoying, sometimes all you have to do is install a little canvas connector, and that kind of helps the problem. Okay, this is a little example of a kind of a full ductwork layout, where we have all sorts of different types of transitions and takeoffs to kind of supply your air and your return air to a room or home. Okay, you also can have your prefabricated ductwork. Okay, these are typically used for all of your branch runs. They can be round pipe, they can be oval pipe, they can be stacked duct. All different types of prefabricated fittings are available for purchase, especially if you are a type of business or a person who doesn't have all of the tools to make the fittings. You can't purchase them. A lot of your round pipe is going to be used in a lot of your floor bays. You may run into it in your attics for places where we're not trying to take up a lot of space in the area. We want to try to maybe conceal some of the ductwork, maybe in a wall cavity or something like that. You'll find a lot of your round pipe and a lot of your oval pipe. Your stacked ducts, that can be rectangular duct used inside walls of anywhere between 2 1/4 to 3 1/4 inch. And there's all of your examples of your round duct. Here's your oval, and then here's your rectangular square duct. Okay, your round elbows, these guys can be turned from 0 to 90 degrees. These guys are adjustable, very, very commonly used in a lot of your HVAC installations. Your takeoffs, they can be, and they must be, in many cases, airtight in your attics, in your crawl spaces, because after all, we do not want to be wasting any sort of energy or any sort of conditioned air to a space where we don't really care whether it's heated or cooled. Okay, some of your takeoffs are adjustable, especially in your basement applications and in your attic applications. Your takeoffs can be installed on the top, your sides, with or without dampers or adjustment dampers in them, so that we can actually raise and lower the velocity of the air coming out of our takeoffs. They can also be squared around or round collar. It all depends on what we're doing. Okay, here is a takeoff with a hand damper. This one here is actually a self-adhesive type takeoff. This area here, this round area, is actually a piece of tape, tape, and underneath there is actually a sticky tape solution that we actually stick on to the piece of ductwork, obviously after we cut a hole into the ductwork so that we can let the air flow through the ductwork. So this would actually get stuck right onto the ductwork and then screwed to the ductwork, where we can now adjust the damper, open and close, to adjust for the velocity within the room. Very, very important if you are trying to balance the air distribution throughout a house so that you're not overcooling or overheating a space. Then you also have your tab type takeoff. These do not have a sticky backing to them. They actually have little tabs that have to get bent over inside the ductwork so that it actually makes a connection. These also need to be sealed. A lot of people use mastic and foil tape to make the connections. I've seen people use caulk. Pretty much any means to kind of seal the connection, you can do it. These are also available with hand dampers or without hand dampers, depending on, obviously who's doing the job. Then you also have your squared around takeoffs with damper, same type of stuff. Then you have your sealing boots, which is a top box and a side outlet. These are what is actually in an attic. And this is what actually shows shows off your registers in your ceilings. Okay, another type of hand damper. Again, these are going to be used for balancing airflow. You also have your terminal or floor and wall boots. These are 90 degrees. Okay, your end boots These are also going to be your constantly found in your in your sides or in your floors. Your oval pipe, okay, these are commonly found, especially if you're going to be taking duct work and sending it through a wall up to maybe possibly a second floor, and the ductwork is actually in the basement. You would use a oval fitting like this. These are specifically designed to fit inside your floor, inside your wall joists, so that you can get airflow from one floor to another. Yeah, and this is what it would kind of look like if it was actually in a wall. Here's your oval pipe. This is actually your header. So this is your type of terminal that's in a wall. Okay, commonly found. These can be used in either on your return duct or on your supply duct. Okay, just another picture of it. It's basically the same thing. Okay, here is a toe kick, or what we find under cabinets, especially in kitchens and sometimes in bathrooms. You'll find that the vents are actually underneath the cabinets, because sometimes it's just what people want. Again, it's just a different type of design that can be seen. Okay, what is important about a lot of these, especially if you are going to be installing ductwork in your walls, what you really need to do, and is very good practice to do, is to make sure that the ductwork, as you can see in this picture here, that the ductwork is actually in the center of your wall joists. And if you notice on the very bottom here, this technician has actually took some fire caulk and actually sealed around that penetration. Okay, that is actually good practice, and I do believe in some areas that is actually code, that any sort of ductwork that's going to be penetrating through a floor has to be fire caulked, obviously for safety reasons. Another very good common practice to do is that they actually took a piece of sheet metal and actually kind of made a protective little covering here, so that it actually protects the ductwork. Another good thing that they've noticed is that they took the wires from the electricians, and it's actually behind the ductwork. Okay, so once that sheetrock goes up, that wire is now actually protected. Here's another really good picture of what we're talking about here. It's actually open. So once this piece is getting put in, our little sheet metal protectors would actually get installed here, and then we would actually fire caulk all the way around. Another very good practice is right where this seam is that we would actually take some mastic and seal this fitting together, and then once that mastic dries, hit it with a piece of silver tape, and then it'll actually be leak free. Okay, another really good picture of how we are actually using sheet metal for supports. Sheet metal screws are screwed right into the rafters, and then our sheet metal is screwed right into the ductwork, where we can actually support the ductwork all the way down your rafters and your floor. Okay, here's some more pictures of some ductwork in the wall. Again, look at how nice this is. This is all nicely insulated and wrapped. Very good idea to do, especially since it's on an outside wall. Okay, another example of some ductwork that might be going up a wall, and then we got to transition into a piece of round duct. Maybe because we're sending that piece of that air maybe to another room, or maybe this is going to be in a bathroom or something like that. All of this should be masticed and taped, just so that we do not have any sort of leaks. Okay, when it comes to duct sealing, it is very, very important to prevent the loss of heating and cooling capacity to those unconditioned spaces. Again, remember, we do not care about those areas that are not going to be conditioned. We want to make sure that we are able to have full capacity of heating and cooling on our pieces of ductwork and delivering that to the spaces where we want it to go. So in order to do that, we have to duct seal. Okay, code enforcement. Some towns require your ductwork to actually be pressure tested. It has to pass inspection and it has to pass the pressure testing in order for it to be sealed and deemed okay for use. Okay, problem spots that you will most likely run into where you're going to have leaks is you're going to be your plenums, your takeoff connections, any end caps that is in use, any pipe seams, and any sort of joints that is in that piece of ductwork. So bottom line is you need to make sure that you are sealing every piece of ductwork that is there, whether it's an adjustable elbow, whether it's a stacked duct, flexible duct, whatever it is, it all should be sealed. And if not, you are running a risk of losing some valuable air, pressure, and spaces where it's not really good to do. Okay, when we are using our aluminum tape, we have to make sure that we are sealing it properly, and in order to do that, we use what is called a squeegee. It's basically a piece of plastic that we run along the piece of tape to make sure that there is no air bubbles or any sort of areas that is not exactly adhesing to the ductwork. Okay, mastic is usually applied with a paintbrush. Okay, and then some people actually use both your mastic and foil tape. Some people actually use glues, caulk, mastic, and tape. It all depends on the company, but very generally it's going to be simply just mastic and aluminum tape that's going to be applied to all of your joints. Okay, here's an example of your mastic. Okay, notice how all of the joints are properly sealed. Now, if this person was to take this one step further, he would have taken this and wrapped this with aluminum tape as well and squeegeed it completely onto the ductwork where it would have now been completely sealed. Okay, obviously if you're using some sort of caulk, obviously you need a caulk gun to do it. Okay, and then there is your foil tape and your mastic. Okay, another example here is this guy here is just simply using some foil tape for all of his joints. A couple of problems that you can kind of see in this image. Well, he has an adjustable elbow here. He did not seal around these joints here with any sort of mastic or silver tape. So this area right here is actually a potential for a leak. He did not mastic down his oval pipe here or use any sort of silver tape along his seams here. So that, again, is also another area of where you can have air leaks.